Good day and welcome to the Math Salon. I'm Dr. Anumendem. Up to now, I've already shared with you some few videos on how to manage quadratic equations. We use quadratic equation formula, we have used completing the square, we have used factorization, but sometimes you have other polynomials that are not quadratic. They are more than just to the order of 2 or to the degree 2. So they're more than the degree 3, degree 4. There it's a bit tricky. So you may have to first guess one of the roots before you can get the other ones. So people have come up with ideas and techniques on how to do that. So today we will try to see how to be able to guess that a root lies somewhere for you to begin. So just let you get this sketch here. Imagine that I sketch a function like this that goes, you can continue. I'm just looking at part of it. Let's say this has two roots. This is my function f of x, this is the axis for that. So every point here is given when you know the point of x. So if I give an x, I get f of x and I get a point here. These places are roots, which means these are the points where the function cuts the x-axis. At that point, the function is equal to 0, like this is equal to 0. So this is equal to 0 at some values of x. And let's say that is the case. Here it is to the power 4, so it's going to do that 4 times. But that's not the case. Here we just want to say, what do you mean when you say a root lies in a certain interval? Notice here that this function goes down. It is positive here because it lies on the positive axis of the f of x. So on this positive side, the function is positive. The function is positive. By the time it gets here, it has gone down to the negative parts. So if you want me, this will be like -1, but this is like 1, something like that. So let me say I look for the function at this point here, a. So this is f of a there. And then this is a point b for x here. This means the function here is f of b. So if I get a point, an x value, and compute the corresponding y value, for example, an x value of a, and I compute the y value, and I see that it's positive, and I take another x value which is away from the other one that I took, let me say b, and I compute the f of that x value, if I notice that there is a change in sign, it means that the function has crossed the x-axis to the other side. See? So if I took another one here, it goes close, but it's still on that side, so it's still positive. Once it changes to negative, I know, oh, I've jumped a root already. So one of the ways to test to know that a root lies in an interval is to test the endpoints of the interval. So if you test the boundaries, you check your function on the boundaries, and there's a difference in sign, it means it contains a root. That's what we were applying these three equations here. It's the same here. Let's say here I came here, I took a value c, and here I took a value d. Then this point here is f of c, and this point here is f of d. If I see that the sign of f of c is opposite to the sign of f of d, then it means there is a root, and that is the case here. F of c is negative, and that is positive. C, on the contrary, if you took an e here, then you would see that the sign between a and e doesn't change. They are both positive, so there is no root there. It doesn't contain a root. These questions come very often in paper 1 and paper 2 of the advanced levels. So if you pay attention here, you can solve any other one that has to do with show that a root of this polynomial, this equation, lies in a certain interval, or look for them. Sometimes you are given options of different intervals. You just have to test the boundaries and see that there's a change in sign. Okay, so we will take the first one. So we'll start with the first one. So we have the x to the power 4 plus x to the power 3 plus 3x squared minus 9x minus 12 is equal to 0. We're to show that a root of the equations, this one and that one, lie in this. So for these two, they all have a root here. And the third one is different. So we're trying to check if a root of this equation lies in this interval. So let me say this function is f of x. Let's just call the function f of x. Then it means that my f of 1 would be equal to, I put 1 here, 1 to the 4th power plus 1 to the 3rd power plus 3 times 1 squared minus 9 times 1 minus 12. If I check that, then this is 1 to the 4th power is 1 plus 1 to the 3rd power is 1. 3 times 1 is 3. Minus 9 times 1 is minus 9 minus 12. If I sum this, I get 5. If I subtract 5 from this, I get minus 4, and that gives me minus 16. Let's do now for f of 2. F of 2, we have to put 2 then. 2 to the power 4 plus 2 to the power 3 plus 3, 2 to the power 2 minus 9 times 2 minus 12. 2 to the power 4 is 16. 2 times 2 is 4 times 2 is 8 times 2 is 16. Plus 2 to the power 3 is 8. 2 to the power 2 is 4 times 3 is 12. Minus 2 times 9 is 18. Minus 12. So yeah, this is minus 30. If I take this and that is 20. And that is 36. So this is 36 minus 20. Minus 30, excuse me. And that is 6 here. So you see, this is positive. So I see that my f of 1 is negative and f of 2 is positive. So if that is true, then it means it contains a root. Let's take the second one. I have to fix it so that it is an equation something equal to 0. So that is x to the power 3. I take this to the other side and I get plus 5x minus 7 is equal to 0. So let me say that is also f of x. Then I will try my f of 1. F of 1 would be equal to 1 to the power 3 plus 5 times 1 minus 7. If I do that here, this is 1 to the power 3 is 1 plus 5. That is 6. 6 minus 7 is minus 1. So that's negative there. F of 2. I put 2 there. 2 to the power 3 plus 5 times 2 minus 7. So 2 to the power 3 is 8. 5 times 2 is 10 minus 7. So that's actually 11. So this is 11. Once again, you see that f of 1 was negative. This is less than 0. And f of 2 was positive, greater than, so it contains a root. Let's see the third one. So that is 2x. So let's just say f of x is equal to this part. You can check that afterwards. So if our f of x is equal to 2x cubed plus x squared minus 3x plus 2 is equal to 0, we have to check that this has a root in this interval minus 2 to minus 1. So what is f of minus 2? This is 2 times minus 2 to the power 3 plus minus 2 to the power 2 minus 3 times minus 2 plus 2 is equal to, we have to calculate that. So let me fix that. So here, if you check that properly, we see minus 2 to the power 3 is minus 8. Minus 2 times minus 2 is plus 4. Plus 4 times minus 2 is minus 8. So minus 8 times 2 is minus 16. Minus 2 squared is plus 4. Minus 3 times minus 2 is plus 6. And then plus 2. Excuse me there. So this is here we get 4 plus 6 is 10, and that is 12. 12 minus that is minus 4. Then we try f of minus 1. So you see this is negative. So if f of minus 1 is not greater than 0, then it does not contain a root. So f of minus 1. So we take back our function there. This is 2 times minus 1 cubed plus minus 1 squared minus 3 times minus 1 plus 2. And this is equal to minus 1 cubed is minus 1. So this is minus 2. Minus 1 squared is plus 1. Minus 3 times minus 1 is plus 3 plus 2. So if you check here, you see this 2 and this minus go off and I get 4. So this is equal to 4. So this was less than 0. This is greater than 0. Therefore, this equation has a root that lies in the interval minus 2 to minus 1. I hope that was understood. Try to practice this with other examples of the past questions. If you have some difficulties, just drop me a comment. Most importantly, give us some thumbs up, subscribe, share with your friends, especially those who don't have telephones or computers or have maybe phones but they don't have money to get data. Share with them in small groups. That's the most important thing. Bye-bye.